Section 2.1 is about graphs of equations and four objectives that we want to meet. One of them is about plotting points associated with ordered pairs of numbers. The second one will be to determine whether an ordered pair of numbers is a solution of an equation in two variables. Then we want to graph linear equations using tables. And the last would be to graph nonlinear equations using tables. Before we do any of this, we need to discuss some of the basics. And so what you're looking at here is the so-called rectangular coordinate system, sometimes known as the Cartesian coordinate system, in honor of the great French mathematician and philosopher René Descartes, 1596 through 1650. His idea was simply this: arrange two number lines at a 90-degree angle that meet at the so-called origin, and that gives us four quadrants, and they're usually designated with Roman numerals: quadrant 1, 2, 3, and 4. And you may notice that the numbering of the quadrants is counterclockwise. Then we also have the idea of an ordered pair. For example, here the ordered pair is 2, 3. And ordered pairs is something that most of you are familiar with, because at least for men, when men buy pants, they usually buy something like a 36-32 or a 42-36 or something like that. Now, of course, they know that the first number is for the waist and the second one is for the length. So in other words, we say it's an ordered pair because the position of the numbers have meaning. If someone has a 42-36, a 36-42 wouldn't work. It's a different pair of pants. So therefore 2, 3, the ordered pair, is not the same as the ordered pair 3, 2. So what happens is that the first number, the so-called abscissa, the first coordinate, refers to the horizontal axis. In many cases, that's called the x-axis. And the second number refers to the vertical axis, or usually denoted by the y-axis. Of course, the axes could be named in many different ways, and we will do that later on, but that's basically it. So what this ordered pair really says is that it's a short form for saying x equals 2 and y equals 3. And that's how you should think about it. You don't necessarily have to say it, but that's what you want to think. So that means we go 2 along the horizontal axis, the x-axis, the first one, and then we go up 1, 2, 3 on the vertical axis. So here's the point 2, 3. On the other hand, this notation means x equals 3 and y equals 2. It's a different point because now we go 1, 2, 3 along the horizontal axis, the x-axis, the first axis, then 1, 2 along the vertical axis, and so this is the point 3, 2. Obviously, they are different points. Sometimes the number long, or the first number is called the abscissa, and the second number is called the ordinate. So here you have it all together. Here's an ordered pair. For example, 2, 3. Here's the first coordinate, 2. And number 3 would be the second coordinate. Here are the quadrants, quadrant 1, 2, 3, and 4, counterclockwise. In the middle is the origin where the two number lines intersect. And here it's positive x to the right and negative x to the left, and positive y up and negative y down. It is absolutely critical that you remember the definitions and have a working knowledge of them. So in this exercise, on these exercises, we're supposed to plot the points on the plane. And so 6, 4 means we go 6 to the right, 1, 2, 3, 4, 5, 6. And the 4 is a positive 4, we go up 4, 1, 2, 3, 4. So here's the point with coordinates 6, 4. Then 4, 6, that means we go 4 to the right, 1, 2, 3, 4, and we go up 6. 1, 2, 3, 4, 5, 6. So this is a point with coordinates 4, 6. The point minus 3, 5, the minus indicates we go to the left from the origin. Minus 1, minus 2, minus 3. That's minus 3, and then 5 is positive, so we go up 5. 1, 2, 3, 4, 5. So this is a point with coordinates minus 3, 5. So got this one here. And then 5, minus 3. So that means first we go 5 to the right and then 3 down. So 1, 2, 3, 4, 5. So the minus 3 indicates go down, minus 1, 2, and 3. So this point has coordinates 5, negative 3. And this point number 5 has coordinates minus 4, minus 3. So we go minus 1, 2, 3, and 4 in the x direction. And then we go minus 3 or 3 down in the y direction, 1, 2, 3. So this is a point with coordinates minus 4, minus 3. Then we have the point 4, minus 2. So that means we go 1, 2, 3, 4 to the right and 1, 2 down. So this is a point with coordinates 4, minus 2. This one here. And then we have a point with coordinates 0, 3. What does that mean? Well, 0 means we remain where we are at 0, and we go up 3, 1, 2, and 3. So this point is not in any quadrant, but it is on an axis, in this case on the y-axis. Okay, so points are either in one of the quadrants or on one of the axes. And then the point 3, 0, well, that means we go 1, 2, 3 to the right, but this tells us we're not going up or down, we stay where we are. So this is a point 3, 0, and that point is on the x-axis, or the horizontal axis. And then 0, minus 4, again, we start at 0, we remain at 0, that's what it tells us here. And we go 4 down, 1, minus 2, minus 3, minus 4. So this is a point 0, negative 4. And again, it's on the y-axis. And this point here, minus 4, 0, says we go 4 to the left, minus 1, 2, 3, and 4. And the second coordinate being 0 means we don't move at all. So this point has coordinates minus 4, 0. So you need to be absolutely certain that you can plot points. That is absolutely impossible, and it's really, really important. It's impossible to make progress here in this particular chapter unless you can plot points in a coordinate system. Here we have some questions regarding points in a particular quadrant. And the first question is, what can you say about the coordinates of a point in the third quadrant? Well, the third quadrant would be here. Remember, this is quadrant 1, 2, 3, and 4. This is quadrant number 3. Let me just indicate that. And when you look at a point like this, you notice that both coordinates are negative, -4, -3. So both coordinates are negative. Both coordinates are negative. Similarly, what can you say about the coordinate of a point in the fourth quadrant? Well, here's the fourth quadrant. And let's look at one of those points. Well, two actually. 5, -3 or 4, -2. And so what you can say is that the first coordinate is positive and the second coordinate is negative. So here you have it. The first coordinate is positive and the second coordinate is negative for a point in the third quadrant. Okay, now let's look at solutions of equations. This is basically just a review of something we have done before. But here the question is, determine whether a given number is a solution of a given equation. So, determine whether the given number is a solution. So here the given number is 5. And the question is, when we replace y with 5, is that a solution? Well, let's see. When we replace y with the number 5, we have -5 times 2 minus 5. The question is that equal to -15? Well, 2 minus 5 is -3. So is that equal to -15? Well, -5 times -3 is +15, and that is not equal to -15. So in other words, the answer is no. For the other equation, we are supposed to replace x with the number -7. So that means we have 2 times -7 -6. The question is that equal to -20? Well, 2 times -7 is -14. -6, is that equal to -20? Well, -14 minus 6 is equal to -20. And that is equal to -20. So this is yes. -7 is a solution of the given equation. In exercise 13, we are asked whether 2, -4 is a solution of 5b minus 3a equals 34. So now here we have a and b. So the question is, what is a and what is b? Well, it's in alphabetical order, so that means a corresponds to 2 and b corresponds to -4. So therefore, we replace in this equation 5 times, and b is equal to -4, minus 3 times, and a is equal to 2. And the question is this equal to 34? Well, 5 times -4 is -20, and -3 times 2 is -6. Is that equal to 34? Well, -26 is certainly not equal to 34, so here the answer is no. This ordered pair is not a solution of this given equation. Similarly, in this exercise number 14, determine whether 2, -4 is a solution of 7p plus 5q equals -6. Again, this is an alphabetical sequence, so this would be p, and this would correspond to q. So in other words, we replace p with the number 2. So we have 7 times 2 plus 5 times q, and q is -4. And the question is this equal to -6? We don't know. But 7 times 2 is 14, and 5 times -4 is -20. So is that equal to -6? 14 minus 20 is -6, and -6 equals -6. So here the answer is yes. Here are the 3 steps to graphing a linear equation. First, select a value for one variable and calculate the corresponding value of the other variable. Form an ordered pair using alphabetical order to indicate, as indicated by the variables. And then number 2, repeat step number 1 to obtain 2 other ordered pairs. 2 ordered pairs are essential, and the third one serves as a check. Because a line is defined by 2 points, but just to make sure it's correct, you always want to have a third one just to make sure. And then plot the ordered pairs on the coordinate system, and then draw a straight line passing through the points. And that's all there is to it. It's very straightforward. So let's try it out here with the next exercise here. And so here the exercise says graph the equation y equals -2x. So now in this example, the values for the variable x are already suggested, so we don't have to think about what to use. So now we just replace the variable x with a given number. So when x is -3, then y equals -2 times -3, and it would be +6. So y is equal to 6. That gives us the ordered pair -3, 6. Then when x equals -1, we have y equals -2 times -1, and that's equal to +2. So you have y equals 2. So we have -1, 2. And when x equals 0, well, that's the easy one. -2 times 0, of course, is 0. So, so that tells us that this line goes to the origin. And when x equals 1, then y equals -2 times 1, and that is -2. So -2. So we have the ordered pair 1, -2. And when x is equal to 3, we have y equals -2 times 3, and that is -6. So we have the ordered pair 3, -6. So let's plot the points. So the first one is -3 and 6. So x equals -3, y equals 6. So we go -1, -2, -3 for x, and then 1, 2, 3, 4, 5, 6 for y. So that's the point -3, 6. Then here we have the point -1, 2. So we go to x -1, and then 1, 2. So here's the point -1, 2. And then here's the origin right here. And then we have the point 1, -2. So we go 1 to the right and 2 down. So here's the point 1, -2. And then we have the last point, 3 comma minus 6. So we go 1, 2, 3, and minus 1, 2, 3, 4, 5, 6. So this is the point 3 comma minus 6. And now we are connecting these points with a line, with a straight line. And then we're going to put arrowheads at the end of the line. And what that signifies is that the line continues indefinitely in both directions. That's true for this equation here. And it's always a good idea to write the equation of the line next to it, y equals 2x. And the reason why is that sometimes we will graph more than one line on the coordinate system, and so we need to identify which line we have just graphed. So it's just a good idea to do that. It's not a requirement, but for you to have clarity about what you did, it is a good idea. Here's an important observation. The graph of an equation. The graph of an equation is a drawing that represents all of its solutions. So let's think about this for a moment, what that means. When we graphed the previous equation, let me just go back to that, we selected certain points and we graphed them, or we plotted them in the coordinate system. Of course, we could have picked any other point as well. So in other words, all the solutions, and there are of course infinitely many solutions, but together they represent the solution set to, in this case, this equation here. So what you're reading here, the statement, the graph of an equation is a drawing that represents all of its solutions, that's just a more general statement. But it's an important one, and it's important to remember it. So here's another exercise about graphing an equation. So here we have a given equation, y equals 2x plus 3. And so in this case, we are free to, or we are not given any point, any values for x, so we can choose any value we want. And it could be a very large one, it could be a very small one. Typically, what I do is I select maybe two values that are not too close together, because when the points are close together, it may be a bit more difficult to draw a line through these points. So if they're a little bit spaced out, like in the previous example, it's a good idea. So let's just choose x equals 2. And I always like to use an easy one, like 0. And let's see, how about minus 2? That would be a good one also, right? Okay, so what this says now, we need to compute the value for y given these values for x. So let's rewrite the equation, y equals 2x plus 3. And let's use the first value for x equals 2. Then that gives us y equals 2 times 2 plus 3, and that means y equals 7. 2 times 2 is 4 plus 3 is 7. So we have the ordered pair 2, 7. And for the next one, for the next value, when x is equal to 0 for this given equation, then y equals 2 times 0 plus 3. And since 2 times 0 is 0, this is simply 3. So that point is equal, or the coordinate is equal to 3. So we have the ordered pair 0, 3. And when x is equal to -2, x minus 2. Then we get y equals 2 times negative 2 plus 3. So that's minus 4 plus 3, and that would be negative 1. So we have minus 2 minus 1. So we have the ordered pair minus 2 comma minus 1. So now let's plot these 2 points. And so 2 comma 7 means we go 1, 2 on the x-axis, and we go up 1, 2, 3, 4, 5, 6. So you have to guess a little bit, but this would be the point 2 comma 7. And then the point 0 comma 3, well, that tells us we remain at 0. We're not going to the left or to the right, but we go up 3. So 1, 2, 3. So that's a point on the y-axis. In fact, it's a special point that we learn about later, but let me just mention it here right now. It is called the y-intercept, where the line crosses the y-axis. And then we have the point minus 2 minus 1. So minus 2 is here and minus 1 is there. So minus 2 minus 1 would be this point here. Minus 2 minus 1. And then we draw the line through these 3 points. And we put arrowheads at the end of the line to indicate it extends indefinitely to the left, above and below. And again, it's a good idea to write the equation of the line next to it, y equals 2x plus 3. Another reason why that's a good idea typically is that this way the reader doesn't have to search for what equation was it that was graphed here. Let's look at exercise number 19. Graph y equals minus 1/2 x minus 3. And what we want to do here, the values we choose for x, is to use even numbers. And this way we will eliminate the denominator. So let's just say we use x equals 2. And 0 is always an easy one, so let's use 0. And let's use negative 6. So let's compute the corresponding y values. So we have y equals minus 1/2 x minus 3. So for x equal to 2, we get minus, or y equals minus 1/2 times 2 minus 3. So minus 1/2 times 2 is equal to minus 1, and minus 1 minus 3 is equal to minus 4. So we have the corresponding y value as minus 4, and we have the ordered pair 2 comma minus 4. Now for x equals 0, y equals minus 1/2 times 0 minus 3. The first term is 0, so it's simply minus 3. So negative 3. And again, we have a y-intercept at 0 comma minus 3, a point on the y-axis. And when x equals minus 6, then y equals minus 1/2 times minus 6 minus 3. And minus 1/2 times minus 6, that would be equal to positive 3 minus 3, and that's equal to 0. So when x is equal to minus 6, then y is equal to 0. So minus 6 comma 0. So let's plot the points. 2 comma minus 4, well, x equals 2 and y equals minus 4, minus 1, 2, 3, 4. That would be this point here. Two comma minus 4. And then the point 0 minus 3 is on the y-axis. We stay at 0, we go minus 1, minus 2, minus 3. So this point is 0, negative 3. And the point minus 6, 0 is minus 6 to the left. So minus 1, 2, 3, 4, 5, 6. And we remain at 0 here. So that's the point minus 6, 0. So that's a point on the x-axis. So now we draw a line through these 3 points. And that is the graph of the equation y equals minus 1/2 x minus 3. So this is the sort of thing you should learn to do. It's, this takes a little bit of practice, but there's nothing inherent difficult about it. The next exercise, number 20, is a guided solution one. So here we are asked to graph 4y minus 3x equals minus 8. In this case, it's a good idea to solve for y first. So here's the original equation, and now we add 3x to both sides. That eliminates the minus 3x on the left side, and it gives us a 3x on the right side, so 3x minus 8. And since this is 4 times y, we now divide the whole equation by 4. That means the 4's cancel out, we only have y, we isolated y. And so by dividing 3x by 4, we get 3/4 x. And minus 8 divided by 4 would be negative 2. So I hope that this has become a little bit of a routine now to solve equations in 2 variables or more, but in this case we have 2. Okay, so let's compute the ordered pairs. So we have the suggestion for x equals 0, and so y equals minus 2, that's the ordered pair. How do we know? Well, when we replace x with 0, the first term becomes 0. So for x equals 0, y equals negative 2. Now, notice that that shows values for x that are multiples of 4 to eliminate the denominator. Okay? So when we choose x to be 4, then 3/4 times 4, the 4's cancelled, we have 3 minus 2, and it would be 1. So it's the ordered pair 4, 1. And when x is equal to minus 4, so then we have 3 times minus 4 divided by 4, so we have a minus 1, and so minus 1 minus 3 minus 2 is equal to minus 5. So minus 4 and minus 5. So now we're going to plot these ordered pairs, and 0, 2, of course, is a point on the y-axis, and that's this one here. X equals 0, y equals 2. Oh, I'm sorry, it's 0 minus 2. Oops, it's minus 2. It's right here. And here's a point 4, 1. So x equals 4. 1, 2, 3, 4. and y equals 1. That's 4 comma 1 here. And then minus 4 comma minus 5 would be 4 to the left, minus 1, 2, 3, 4, and then minus 1, 2, 3, 4, 5 would be this point here. So minus 4, minus 5. Of course, we know it's in the third quadrant because both coordinates are negative, and this was the point 0, comma negative 2, and this is the point 4, comma 1. And so again, we use a straight edge to draw a line through 3 points here. The point minus 4, minus 5 is here. Here's the point 0, minus 2, and here's the point 4, comma 1. We put arrows at the end. And we write the equation next to the line. 4y minus 3x equals minus 8. So that's the graph of this equation. Exercise number 21 asks us to graph the equation 5x plus 2y equals 4. So first of all, let's solve that equation for y. So we begin with 5x plus 2y equals 4. To isolate y, we subtract 5x on both sides, so we get 2y equals minus 5x plus 4. Then to isolate y, we divide both sides of the equation by 2. So that means we isolate y now. 2y divided by 2 is y. And minus 5x divided by 2 is minus 5 half x. And 4 divided by 2 is 2. So this is now our equation solved for y in terms of x. So let's use some numbers here. And let's use x equals 2. Let's use x equals 0. And let's use x equals negative 2. And then the reason I'm choosing the 2's is to eliminate the denominator of 2. So when x is equal to 2, then we have y equals minus 5 divided by 2 times 2 plus 2. So the 2's cancel. We have minus 5 plus 2, and minus 5 plus 2 is equal to minus 3. So y equals minus 3 when x equals 2. Now for x equals 0, y equals minus 5 divided by 2 times 0 plus 2. Well, this term is 0. So in other words, y equals 2. So when x is equal to 0, y is equal to 2. And when x is equal to minus 2, we have y equals minus 5 times minus 2 divided by 2 plus 2. And so minus 5 times minus 2 is plus 10. And plus 10 divided by 2 is 5. Plus 2 equals 7. So when x equals minus 2, y is equal to 7. So now all we have to do is plot the ordered pairs. And the ordered pairs would be 2, comma, negative 3. That would be 0, comma, 2. And it is minus 2, comma, 7. So 2 comma minus 3, so we go 2 to the right and 3 down, minus 1, 2, 3. So this is a point 2 comma minus 3. And 0 comma 2 would be this point right here. X equals 0, y equals 2. And the point minus 2 comma 7, we go 2 to the left, minus 1, minus 2, and we go up 7. 1, 2, 3, 4, 5, 6, 7. So it'd be approximately here. So that's the point minus 2 comma 7. And again, we draw a line through these 3 points. And this is a graph of our equation. This is a graph of the equation 5x plus 2y equals 4. I sincerely hope you are able to follow this example and that you can do this on your own as well. This part deals with graphing nonlinear equations, and so far we've graphed linear equations, and we've seen that those graphs are straight lines, and that's why they're called linear equations. But there are many equations whose graphs are not straight lines, and here's some examples. So here the equation is y equals x squared minus 4x minus 3, also called a second order equation, because the variable x is raised to the second power and has this shape, the shape of a parabola, as it turns out. The other one, y equals x to the third minus 2x squared minus 4x plus 2, that is a third order equation. And to graph that, well, you have to plot quite a few points, and it's not as simple, because how do you know where the lowest point and the highest point is, relatively speaking, and so on. But anyway, now we are asked to apply this knowledge to graphing a nonlinear equation, and the nonlinear equation is 4 minus x squared. It's nonlinear because the variable x is in the shows up as a second power. So it'll be a parabola as well. Now we are given some suggestions for the point for the values of x, and so now we are supposed to compute the corresponding value for y. So let's do that. So when x is equal to 0 in this equation, and let me rewrite it as y equals 4 minus x squared. So when x is equal to 0, of course, then this term is 0 and y equals 4. Okay, now when x equals 1, we have 1 equals 4 minus 1 to the second power, which would be 1. So 4 minus 1 is equal to 3. Now when x is equal to minus 1, y is equal to 4 minus negative 1 squared. And negative 1 squared, of course, is positive 1. So we have 4 minus 1, and it would also be 3. So remember the order of operations. We square the minus 1 first. It gives us a positive 1. And then we have a minus sign, which is this minus sign here. Therefore, the answer is 3. Then here x equals 2. So y equals 4 minus 2 squared. And it would be 4 minus 4. And that's equal to 0. So y equals 0 at that point. When x is equal to minus 2, y is equal to 4 minus negative 2 squared. So we have 4 minus, and negative 2 squared is positive 4, so we have 4 minus 4, and that is also 0. When x equals 3, we have y equals 4 minus 3 to the second power. That's 4 minus 9, and that's equal to negative 5. So it's 3 minus 5. And when x equals minus 3, then y equals 4 minus negative 3 squared. So it's equal to 4 minus 9, and that's also equal to minus 5. So you really want to think about what these expressions mean, and I hope it's clear to you. If you apply the order of operations, that should be no problem at all. And if you need to review it, then please go to the book and look up under order of operations. Okay, so now all we have to do is write down the ordered pairs that we have. So we have 0, 4, and we have 1, 3, and we have minus 1, 3, and we have 2, 0, and we have minus 2, 0, and we have 3, negative 5, and we have minus 3, minus 5. So 0, 4 means x equals 0, y equals 4. That's this point here. So that's a point 0, 4. 1, 3, we go 1 to the right, we go 3 up, and that's this point here. 1, 3. The next point, minus 1, 3, means we go 1 to the left, we go up 3. So minus 1, and then 1, 2, 3 up. It would be this point here. So this is a point minus 1, 3. And then 2, 0, 1, 2, and then we stay on the x-axis. So this is 2, 0. And the next one, minus 2, 0. We go 2 to the left, minus 1, 2, and we stay on the x-axis. And then we have 3, minus 5, so x equals 3, 1, 2, 3, and then minus 5. Minus 1, 2, 3, 4, 5. That would be this point here. And then that's 3, minus 5. And then minus 3, minus 5, we go 3 to the left, minus 1, minus 2, minus 3, and we go down 5. Minus 1, minus 2, 3, minus 4, minus 5. And that would be this point here. Minus 3, minus 5. And now we'll connect these points with a line. Now that line is not straight, it's curved a little bit, so we cannot use a ruler. So we do it freehand as best as we can. Now notice that this is not a V here at this point. It is kind of gently rounded. And then it comes down on the other side. Again, we put arrows at the end to indicate that the line extends indefinitely in this direction. Exercise 23 asks us to graph y equals 2 divided by x. Now it may seem that this is a linear equation, but it's not. The reason it's not is that the variable is in the denominator. And so we have a nonlinear equation for that. But anyway, as before, let's compute the corresponding y values for the given x values. So when x is equal to 1, and the equation says y equals 2 divided by x, when x equals 1, y equals 2 divided by 1. So y is simply equal to 2. And when x is equal to 2, then y equals 2 divided by 2, so it means y is equal to 1. And when x is equal to 4, y is equal to 2 divided by 4, which is equal to 1/2, or 0.5. Now, when x is equal to -1, we have y equals 2 divided by -1, which means it's equal to -2. And when x is equal to -2, we have y equals 2 divided by -2, and that's equal to -1. And when x is equal to -4, then y equals 2 divided by -4, which would be -1/2. Now, when x equals 1/2, then y equals 2 divided by 1/2, and that's equal to 2 divided by 1 times 2 divided by 1, the reciprocal multiplied by the reciprocal, so it's equal to 4. So if this gives you a little trouble, 2 divided by 1/2, so it's 2 divided by 1/2, that's 2 times 2 divided by 1, or 2 divided by 1 times 2 divided by 1, which is 4, right? So similarly, when x equals -1/2, y divided by y equals 2 divided by -1/2, that becomes a -4. So here you have the calculations for the values of y. I'm going to leave it here for you to take a look at this for a moment, how these numbers were arrived at. And this may be a challenge here, but I hope it's not too bad. 2 divided by 1/2, that you can do that correctly. And 2 divided by -1/2, that's equal to -4. And I'd like for you to work that out on your own. Okay. However, now we have the ordered pairs. So if the ordered pairs 1, 2, 2, 1, and 4, 1/2, and we have -1, -2, and we have -2, -1, and we have -4, -1/2, and we have 1/2 and 4, and we have -1/2, -4. So let's plot these points and see what we get. 1, 2, 1, 2 is here, and 2, 1 would be this point here. 2, 1, this 1, 2, and then we have 4 and 1/2. So this point 4, 1/2. Then when x equals 1/2, then y equals 4. So this 1/2, 4. So here are the 4 points. And now we'll connect them with a smooth curve. Then I also graphed the other points. -4, -1/2 is here. And -2, -1 is here. And -1, -2 is here. And -1/2, -4 is there. And I connected that with a smooth line. And so what we're looking at here are the 2 branches of a hyperbola. And I remember when I went to high school and university later on and all of that, and I learned about these things over again, and I thought, hyperbolas, I probably never ever see one of those. Well, Believe it or not, when I worked for NASA, I saw quite a few hyperbolas. And maybe during office hours we can talk about that. And it was kind of a fun experience to see an old friend, hyperbolas. Who knew? And please note that this hyperbola has two branches, one on this side and one on the other side, all from the same equation. Exercise 24 asks us to graph an absolute value equation, y equals 4 minus absolute value of x. So let's compute the corresponding y values. So when we have the equation y equals 4 minus absolute value of x, when x equals 0, we have y equals 4 minus absolute value of 0, which is 0, so it's simply 4. When x equals 2, then y equals 4 minus the absolute value of 2, which is 4 minus 2, or it is 2. When x equals minus 2, then y equals 4 minus absolute value of minus 2. And we know the absolute value of minus 2 is 2, so we have 4 minus 2, and that's also equal to 2. And when x is equal to 4, then we have y equals 4 minus absolute value of 4, which we know is 4 minus 4, and that is 0. And when x equals negative 4, then we have y equals 4 minus absolute value of minus 4, and the absolute value of minus 4 is 4, so we have 4 minus 4, and that's also 0. Now remember, the minus sign, that's this one here, okay? So be careful not to think like the minus times the minus is a plus, any of that. That's totally unrelated. Here we're subtracting an absolute value of a number. Similarly, when y is equal to 5, we have x equals 5, we have y equals 4 minus absolute value of 5, which is 4 minus 5, and that's equal to negative 1. And when x equals negative 5, we have y equals 4 minus absolute value of negative 5. And the absolute value of negative 5 is 5, so 4 minus 5 is negative 1. So here we have the ordered pairs, 0, 4, 2, 2, minus 2, 2, 4, 0, minus 4, 0, 5, minus 1, and minus 5, minus 1. So let's plot these ordered pairs on the coordinate system. So here we've plotted the points 0, 4, 2, 2, 4, 0, and 5, minus 1. And here we have minus 2, 2. Here we have minus 4, 0 on the x-axis, and minus 5, minus 1. And now we're just going to connect those points with a straight line. And that would be the graph of the equation y equals 4 minus absolute value of x. So y equals 4 minus absolute value of x. And this concludes section 2.1.